I gotta watch it because this is where I lost my other camera.
Not good. Okay, we don't have any traffic at the moment, so I'll get started.
Yes, go ahead.
Harold's heard this before. Oops. This is the Middletown granite gneiss here, and it's about 1,100,000,000 years, or 1,100 million. So this is the oldest rock in Maryland. Now, in terms of the age of the Earth, that's not that old. The Earth is over 4 billion, so this is only 1 billion. But that's still a long ways back. It started out as a granite, and as a granite, it was formed in the underlying granite magma chambers at a subduction zone, very much like this would be found today underneath the Cascade Mountains. Very shortly after it was formed as a granite, it ended up in a collision zone, plate tectonic collision, constructing the supercontinent of Rodinia. I guess most everybody has heard of Pangaea by now. You know, probably the average fourth grader might have heard of Pangaea. But nobody's heard of Rodinia. What people don't realize is that there have been probably at least half a dozen supercontinents back in the Earth's history. Pangaea is just the most recent one. Pangaea was 250 million years ago. This is a little over 1 billion. What collided with North America then, or what collided with this part of North America in Maryland, is probably what is today northern South America, because a rock very similar, a rock very similar to this is found in the northern part of Colombia in the Sierra Nevada de Santa Marta on the north coast of Colombia. And about 800 million years ago, Rodinia broke apart, just like Pangaea, and the part of South America that had collided went drifting back to the south again, and it's now on the south side of the Caribbean in northern South America, in Colombia. We don't know that much about Rodinia. We know a lot more about Pangaea, and that's fairly typical. As you go farther and farther back, the evidence for each successive supercontinent becomes messed up by the activity in making the next one. Because this is the second time that this area has been collided with. The first time, well, probably not the first. The first we know about was this one 1 billion years ago, where South America hit, followed a few 100 million years later by Africa colliding, and the collision of Africa messed up a lot of the evidence for the South American one. Anyway, so because this was very high grade metamorphism, that means this was very deeply buried at one time. Okay, what happened? You know, Himalaya type mountains. Those mountains went away. They were eroded away completely down pretty close to sea level. And then when the supercontinent broke up, there were major, really major basalt flows that came out called flood basalts. Today they are no longer basalt, but greenstone, because they too have been metamorphosed by the later collision when Pangaea was made. Okay, if we move a little bit, just a few tens of feet up this gully here, we'll go take a look at the next rock. not very green. It's probably violet. A lot darker. Has been decomposed. This is about 700 million years old. So it's about 300 or 400 million years later. And it came out as a flood basalt when Rodinia started breaking apart and thousands of square miles were covered with lava. Now, the lava in most places isn't preserved, but you can see it all up and down the Appalachians where it broke apart again. A lot of this rock can be found on either side, except that it's deeply buried. We don't get to see it in western Maryland, but presumably these same rocks would underlie western Maryland. Rock equivalent to this is also found down in Mexico as well. The equivalent of that granite gneiss back there, that particular mountain building period is known as the Grenville orogeny, after similar rocks that are found at the town of Grenville, Quebec. And it underlies much of the Canadian Shield in Ontario and Quebec. It also underlies the interior of the Blue Ridge, all the way down through to North Carolina and Georgia. Going the other direction, you can find the same rock in Scandinavia, because it was split apart by the Atlantic. And of course in northern South America, where a piece of it rifted off and formed the core of northern South America. So here we can find right here in this particular set of outcrops, we have the evidence for the assembly of the supercontinent. That's the granite gneiss itself. And the evidence for the breakup of that supercontinent. That's the flood basalt, now greenstone, that you see here. On our previous stops, we saw the evidence for the assembly of Pangea. That was the folding and the faulting of the rocks that we saw. And the evidence for the breakup of Pangea, which was the Rift Valley that we saw at the creamery, the evidence for the Rift Valley. Okay, any questions on this? Okay, we got 2 more stops, so let's go on to the next one. By the way, this is a famous enough stop that I have stopped here on occasion. One occasion.